Hi, welcome to the section on C. Here we are going to see a couple of services that OS provides for the developers like us who develops programs and execute on the system. Now, what is the role of operating system in this? And then when you bring an application or a software, a simple hello world program also, when you need to run it on a system, what all needs to be there in the main memory for it to run on the system. So let us see these three things in this section 1C. Important service that OS provides is a platform for program development. Now, as I mentioned in the earlier lecture, the different layers of the systems are shown here. We have the hardware, OS, and utilities and application program. Now, when you want to develop an application, what are the services that you need from the operating system? Of course, there is an IDE, integrated development environment, that you need, and then lots of tools in the background for us to develop the software. That is, we can develop the software using editor, and we need to choose a language which this IDE supports. And once we have written the program, we want that to be edited program to be compiled, linked, and executable has to be created, which can be run on the system. Now the execution part of that comes later, but we are only concentrating on program development in this service one. Now what are the utilities that we use? They are typically, these services are in the form of utilities, while not strictly part of the core OS. Okay, these utilities are not part of the OS, but they are supplied with the OS sometimes, and is referred to as an application program development tools. Okay, it's IDE or development tools. So on Windows we have a very popular Visual Studio or Visual C++, an environment which is used popularly for program development. In to take any language, either C, C++, Java, or whatever language you want to, Python, you can use it. You can develop programs using the environment. Now this Visual C++ is meant for C++ development, which is basically even built with the same language. But Visual Studio is one example where right now a lot of people are using it on Microsoft platform. Now on Windows, we have many IDEs which are popular. CodeBlocks is one, and Eclipse is much more powerful and open source. Any of these, they are also available on Windows. Now, Visual C++ or Visual Studio are on Windows, and Eclipse CodeBlocks on both Windows and Linux. Now, what is on Mac OS? It's Xcode. There are many other IDEs which you can use. Now, what do you need finally once the executable is created? How do we run it on the system? Now, before that, let us just give a go through the sequence of operations that happens when you develop a program. Either it could be C or C++. We use an editor to develop the .c or .cpp file, which is compiled using the backend tool which is called compiler. IDE provides different kinds of compilers. It could be GCC or from the different vendors. Now, what is the role of compiler? It takes in the C program, makes sure that you follow the syntax and semantic rules of the language while developing the program, and it verifies that it is written properly, and then it provides you an obj file, which is a binary form of assembly instructions for which on which the hardware this program is likely to be run on or going to be run on. So when you have a compiler, there is a front end of a compiler, and then there is a back end. Now in between there is a intermediate representation. Now what happens in the front end is it is aware of the language in which the program is written, whereas the backend is basically aware of the hardware for which the code is getting generated. Now, what is this intermediate representation? This is a independent representation of the program in a generic language, which is understood by the compiler. The reason that IR is provided is whenever you are making use of a compiler implementation, we can actually, based on the language, these modules can be reused, and this IR, once it is converted, then we can actually perform some optimization on them. Okay, we will come to the optimization part later, wherein we can optimize the code generated either for speed in terms of execution or for memory, which actually refers to the amount of footprint or the amount of memory the program needs. So the intermediate representation is some language which is independent of the programming language that you are making use of while writing the program, or the assembly program that it is generating, which is very hardware specific. So this IR is independent of those two. So because of that, what happens is whatever optimizations we are doing at the IR level, it can be reused across different compilers. Maybe the compiler may be meant for C++ and generating a code for ARM, or it could be a C code and generating the assembly for Intel processor. But the IR could be same, and we can do the optimizations on that and then generate the code for a specific hardware. So once we have a compiled output, what happens is different C files we may be having, which are being independently compiled as OBJ files, and then we will be linking the library, which is CLib or some library files. It could be SO shared object, or it could be a static library. Now, even the C library like printf and scanf, they are all implemented and given as a library for end user to make use of. Well, we are not implementing the printf for any of those library functions ourselves. We write our own code making use of those C library functions and link along with the library and generate the executable. So once the executable is ready, it could be loaded onto the memory. Now is what the program execution part of it comes, and when you are having a executable ready, which is actual implementation of your code along with the library built. Now we want this executable, which is normally given in a generic format, a template, but it adds information about different parts of the program that you have written, and it needs to be understood and loaded onto the main memory for the program to run on the system. Now let us look at what all is involved and what does the OS or the loader, which is a system services provided by the OS, does. Now a number of steps need to be performed to execute a program. Now what are they? We need to get the resident set. Now what is the resident set of a program? Now if you know, I'm sure you are aware of, any executable that you build is actually a program that somebody has written. Now, while writing the program, I might have used some data, maybe an array of some integers or float or whatever, and I might have given some instructions for how to manipulate the data. So, your executable has a code, which is another name is for as a text, which is assembly instructions of all the implementation that you have done as a function, or inside a function you might be calling another function. So there could be multiple files of those implementation. They are all form a code part of the executable. Now what is the data portion? That could be the data variables that you have declared as a global or static. They all come under the data. Now, what is stack? This is the part of the program wherein you will be calling a function with some parameters, and then inside the function you may be having some local variables, and then you int I or some for int I equal to 0, then I less than something. So this I as well as the parameter that a function is receiving, they are all maintained in the stack. So the stack is the one which is growing or shrinking based on the usage of program or based on the running of the program. So they need to have some space in the memory, because as you are aware, all the variables that you are having either as a local variable or global variable, they need to be in the memory, but they reside in a different part of the memory. So when we are loading a program, we need to make sure that all these three parts of the program are brought into the main memory. Now why is that main memory is so important? Why am I saying that they need to be brought? But where is it brought from? It is brought from the hard disk, because we are having hard disk where our executable is residing in our file system somewhere in our directory structure. We would have given some abc.exe. So that file is stored in the hard disk. but CPU needs to now execute it. That means it should know where the code is, where the data is, and where the stack is. So the CPU needs to access that. Then they need to be brought into the main memory, which is nothing but the 4 GB or 8 GB RAM what you have in your system. So who is doing that job of bringing the executable from hard disk to the main memory? That is the job of the OS or the loader part of the OS. Now, loader is a program, a system software which understands the executable, because executable itself is given in some format, in a binary format. It opens up the executable file and understands the different parts of the code and data and stack memories of this executable, and then it brings it to the area which is allocated by the OS again. See, you understand that the main memory is also shared between different applications. Of course, main memory is shared not only with the other applications, even the OS is residing in the main memory. So for a OS to run, they need to be in the main memory. I will explain it now shortly with the picture. So it is running from the main memory, even the OS. Then it is sharing space with the main memory with other applications. So when you are running an executable, they are brought into the main memory before the control is given to the application and the CPU starts running from there. So instructions, data, stack, they are all called precedence set. Program need to be present on the main memory before the execution starts. Now, I/O devices like a hard disk must be initialized, and other resources for loading the files onto RAM must be prepared. Now, when you are executing the program, we need to make sure that the hard disk is accessible, and there are some device drivers which are helping the OS to understand the way a file is stored in the hard disk, because OS may not be aware of individual construction of the hard disk. So that is provided by maybe companies like Samsung or Western Digital. They also give hard device drivers meant for particular OS. It could be on Linux or Windows. They provide the device drivers which are specific to the OS as well as to the hardware. So device drivers come in between the OS and the hardware. Device driver has knowledge of the hardware as well as how to interface itself with the OS, because it accesses the hardware, like in our case hard disk, and then gets the data, puts it in its own buffer, and then gives it to the OS to be loaded into the main memory. So that's the flow of information coming from the hard disk to the main memory. Similarly, when you are changing some files and then updating the file and saving it into the hard disk, the same thing happens in the reverse direction. So, example, Windows does all the above while this PowerPoint presentation is being shown now. Okay. Now let us see what all is present in the main memory. For a program like PowerPoint, for me to run this particular slideshow, remember the main memory I am showing as an entire main memory, which is maybe a 4 GB or 8 GB that I have. Now, remember, before even the system is brought up, kernel is already residing in the main memory. Who is doing it? While the booting sequence happens, when you are booting up your machine, already BIOS is running initially to check that all the hardware is checked, which is BIOS is nothing but basic IO, input output system. So base BIOS is making sure that the RAM is tested and the hard disks or other devices are checked, and then the OS is booted. That means it is brought into the main memory and protected. So this main memory part of Windows where it is residing cannot be accessed by any other user applications running in the same main memory. So there are two modes of operation which I will come to that later. Now once the OS is residing, it can now give control to you, and login prompt comes up and you log in as a user. Then now when I want to bring up a PowerPoint file, I indirectly inform the OS to bring up the PowerPoint program first, because the PPT file can be understood only by the PowerPoint program which is developed by Microsoft, of course. So that tool has to be brought in. It is common even for if you want to bring a Adobe's Acrobat read, or PDF can be read by any other things, or maybe you want to open up a JPEG file, or you want to play a video, maybe using a VLC player. Now those applications need to be accessed. They need to be brought first. Remember, the formats of the files are understood only by those programs. PDF cannot be understood by every program in the system. So you need to bring up a program which understands the PDF format. PDF is a specific binary format in which a program is stored in the hard disk. So similarly, PPT is also a binary format which is actually capturing the way you have written the slides, and what is the font, and what is the content, and what are the pictures, what are the pictures you have in them. Maybe you may embed a video in the PowerPoint, so they need to be understood by the PowerPoint program, which has to be running on the system. Now, whether you need to have one version of this PowerPoint, or maybe a same PowerPoint version, or a instance, not an version, an instance of this PowerPoint can be only one instance of the PowerPoint, even if you are having multiple PPT files open in your system. So that's how initially the PowerPoint official Office tool is brought into the main memory. When I say a PowerPoint is brought in, you can imagine that it has its own code and data and stack. Similar to Windows also, or any Linux operating system running, they also have their own code and data. Any program needs to have all of them, and all of them need to be in the main memory. I'm leaving out Heap, which is memory dynamic memory allocation based on the uh, library, which I will come to that later. Now, once I have this session C file open, I can actually see those contents. Now, when I am skimming through those pages need not, all the pages need not be brought into the main memory. Whenever I want it, then those pages are brought into the main memory. The reason why everything is not brought, because main memory is limited. It is not only shared, it's not only used by one program, which is PowerPoint. You know that in a Windows or any system that you have, you might have opened many applications like Chrome browser or any other Firefox browser, or you may be playing a VLC player, or that YouTube may be open. So many things, applications and browsers and any applications are running on your system. They all share the same main memory, which is limited in size compared to hard disk space, which is unlimited. So even then, in a physical system like us, we have a limited few terabytes of memory. I'm saying terabyte is limited, but actually it has become common now. So this is how a main memory is shown if you want to say an application is running in a system, or it's opening a file. If it is multiple files are open, then we may have to bring those multiple files onto the main memory. Okay, all the pages may not be there, but the page that you are currently in should be available in the main memory for you to see it on the screen. So how is an executable loaded into the DRAM? This is a, you can freeze this video and read through this content. Whatever I explained here is more or less given in this particular ChatGPT generated information. Just I wanted to show you how ChatGPT is able to gather information about what I am looking for and provide a meaningful information about it. So there is a word called demand paging. That's what I meant by saying that only what is needed is brought into the main memory. And when you are now going to the maybe last page, when you say go last page, then you are interested in going viewing the contents of the last page, then the last page is brought into the main memory, and that's called demand paging. Whenever what you need is brought into the RAM. Now, before I end the program in this video, just wanted to show you, suppose if I have a static variable s, int s equal to 100, and then I have a function, maybe a main function, then there are some variables inside them, local variables, and then I also have some global variable g initialized to some value. Now, as I said that you have a program, it has a resident set. This part of the code, whatever I have written, is available on the code or a text segment of the program, which is also going to be in main memory. Remember that different code and data stack have a different access permission as far as the program is concerned. Based on that, access permissions are given and controlled by the operating system. Now, one good example is code needs to be readable, because I want to read the instructions stored in there, which CPU reads it and executes it. So it should be able to read and execute. Now, X is the name given for execute permission. So this part of the segment is read and executable permission. Whereas some data, maybe I may have a const data, then it's only a read only data. Okay, it's only read permission is given, no write permission or execute permission. Now, what about data which can be read and writable? Suppose if I have int g which can be modified, I should be able to write into it. So the CPU should be able to write into the data which is in the main memory. So it should be read writable, read and write. But I don't want this particular part of the memory to be executable. because we are not storing the instructions here, assembly instructions here. If I try to give execute permission for the data and then the CPU by mistake reads this part of the memory and tries to execute it, it will encounter illegal instruction exception. So that should be avoided. So OS make sure that CPU by mistake does not read different parts of the memory for different purposes. It should read for a particular purpose for which those different segments are built for. So these are the read and write permission. Now what about stack? Most of the time when you have local variables passed to a function or the local variables, if they are not constant type, they will be in the stack and we need to read and write permissions we need to give. So mostly the stack part of the memory is read and write permission is given to it. So this is a good example of how a C program, a resident set of a program runs on the main memory. So remember, when you want to run even a small program like hello world, the string hello world has to be into the main memory. So most of the time what happens is even the strings are kept along with the code area of the program. It depends on the tool. It can decide to put it in the code area because accessibility is easier because strings are accessed from the code, and normally what happens is string is of course read only because you cannot modify once the string is made. So they are stored along with the code, though it's not actually executable part of the code. So this we would have given you a good overview of how a program is first of all created, executable is created, and how they are stored, and how different parts of the memory or variables are stored in the memory. Okay, so with this we come to the end of this section. Let us see some more interesting stuff in the coming sections. Bye bye.